Hey gang, this is a short video to introduce the activity today, which is it's called Safe to Launch, question mark, safe to launch. There is a video which comes with this. It's already posted with this assignment, in which case you get to watch for a couple minutes carrier operations when they're launching jets off of an aircraft carrier. And I put that video in there partly because it's cool, but mostly because I want you to be able to visualize what this task is asking you to do. So, in a nutshell, you are working on an aircraft carrier, and your method for seeing that the speed is right at the end of launch is not working right. So you have to find another way to calculate whether the catapult is working properly. Okay, um, so um, yeah, that's it. And then you're going to be writing a short memo for your boss. You're going to say whether it is safe to go, which means go, or not safe to go, which is no go. And you have to declare that clearly in this memo to your boss. Are we safe to go or not? Answer that question definitively and explicitly. Don't just give her the information and let her figure it out. You need to take a stand. Are we safe to launch or not? And then, having made that decision, then you have to include supporting information. So the math that you do to show that you are safe in the terms that you need to be safe. All right, let's find this here. So, what are we given in this one? We are given distance and time. So, as you read through the memo for the setup, the handout there, which is also posted with this assignment here, you're going to have to find what the distance is that the planes move as they're launched. In other words, the length of the catapult and how much time it actually takes them to go. Okay, and that is in the information. Let me find this again. I do want to point out one thing because this is an error that students make, and I can catch it with students that are going in class, but those of you at home won't see this. This first paragraph is about what the catapult should do. If it's working properly, this first paragraph is what it should do. You don't care about that. You care about what it actually is doing, and your job is to figure out what it actually is doing. So sometimes I have students turn something in or try to turn something in where they just do the analysis of what it should do and say, yeah, it does what it should, and they've actually done nothing. So make sure you are focusing on what the catapult actually is doing and not just what it should do. So you're given the distance, the length of the catapult, and the time that it takes for the plane to get to the end. Now, what do you do with this information? First, you have to recognize that there are two questions that you need to answer. There's a limitation for the acceleration that the plane can go, and there's also a limitation for how fast the plane is going when it reaches the end of the cat. So think about this. If the plane is not going fast enough when it gets to the end of the boat, it doesn't have flying speed. It's going to splash in the water, and that's bad. However, if the acceleration is too high, then the device which actually pulls the airplane down the catapult will be pulling too hard and could literally break the airplane. You might snap off the front wheel because that's what's attached to the catapult, or you might break the plane somewhere in the middle, somewhere between the front wheel and the back wheels. And obviously that's very bad. So too high of an acceleration can damage the plane because it breaks it as it's being pulled down the cat. Too low of a speed off the end of the cat means that it can't fly, and that also damages the plane. You have two questions you've got to answer. Make sure you're aware of both of those and address both, show the math for both. Now, you need to choose your equations for this, and for this, you're going to use the study guide, which is in the stream, as you know. It's the thing that has all the equations on it. So what you need to do is look at this menu of equations that you have and find some that have the information that's given and only leave you with one unknown. Now this right here, V equals delta D over delta T. Well, you have a distance and you have a time. So that's a candidate. A equals delta V over delta T. Well, we don't know the acceleration. We don't know the velocity, even though we do know the time. So you can't use this one right out of the box, although you may be able to figure one of these out, figure out either the acceleration or the change in velocity, and maybe feed this. So you can't one step it, but it may be like a second step you can do. V equals AT, that's the same equation as A equals V over T. V equals G over T is also the same there. So These don't look like they're going to work right out of the box, although you may be able to work your way to them. Okay, d equals 1/2 at squared. We know the distance and we know the time, and this one will tell us acceleration. So this is also a candidate. So for starting, you probably want to use one of these two, either v equals d over t or d equals 1/2 at squared. This one here, you don't need because, as you can see from the video, the planes start from a 0 speed. So the initial speed is 0. So in this case, both of these equations are the same. So if you're going to use one, this is the one you're going to use, d equals 1/2 at squared. You will never have to use this one here. Okay, so you need to think about what equations you're going to use to answer the questions, and you get them off of this sheet. Let's go back to this one here now. Okay, so you're going to choose your equations, and then this is very, very important. You need to think about what the equations are telling you. Like when you plug numbers into these equations, are they giving you an average speed or an instantaneous speed? Are they giving you an average acceleration or an instantaneous acceleration? You need to think about that and distinguish between those two. One thing that you can do is to solve this problem two ways. I kind of indicated that there are two equations which may work to start with. Plug numbers into both of them and see if you get the same answer. If you get different answers, that suggests that maybe one is an average value and the other is an instantaneous value. So you need to distinguish which is which and decide which one you care about. All right. So this is actually a very major concept in this exercise is what kind of values you need, average or instantaneous. Okay. Let's see. I think that's what we've got. You're going to, you're going to watch the video. You're going to write the memo. You're going to read the directions on this thing. Read it carefully, and then you're going to write the memo, support it with math, and turn it in. All right, good luck, have a great day, and we will see you next time.